Welcome to Karen's Lab. Today we're going to learn about a key concept in nanotechnology, surface area. And in the following video, we are going to relate surface area to our nutrition, to our health. Okay, but first to start with, what is surface area? Well, it's the area that is exposed to the surroundings. For example, in chemistry, if this cube were made out of iron, the atoms on the surface will protect the ones on the inside from corrosion. Only the outside will corrode. In batteries, for example, we store charge on the surface. So if we were designing a battery and this was our material, the charge will be stored on the surface. All of the inside will probably be wasted. In biology, for example, when it's very, very cold, why do you go like this? To minimize the area of your body that is exposed, or the surface of your body that is exposed to the cold weather, and that way you can keep yourself warm. When it's hot, you actually go like that. You open up, and especially if you're in front of a fan, because you want to cool down faster. Okay, back to this cube. The surface area is the sum of all the areas of all the faces. The area of each face will be the area of a square. In this cube, we have how many faces? We have 6. 1, 2, 3, 4, 5, and 6. Each one, it's 10 centimeters by 10 centimeters. So the surface area will be the surface area of this square, which will be 10 times 10 is 100, times 6, which we have 6 faces. So that would be 600 square centimeters of the whole cube. If we remove these faces and we place them on a mat, we have 10, 20, 30, and then we have 10 and 20. So that would be 30 times 20, that's 600. That is clear, right? That's the surface area of this particular cube. What about if we divide this cube into smaller cubes of 1 centimeter? Let's take a look here. So now we have this cube and we divide it into smaller ones. Well, the surface area of each one of those 1 centimeter cubes is going to be 1 in the length, 1 in the length. So that's 1 times 1 times 6. Each one of those 1 centimeter cubes have 6 sides. So that would be 6 square centimeters for each cube. And if we multiply by the number of 1 centimeter cubes that we have in this cube, that would be 10 times 10 times 10. That would be 1,000 cubes of 1 centimeter times 6. So that would be 6,000 square centimeter. Same mass, but we have higher surface area, a little bit higher. So for example, in the case of the battery that we talk about, well, we will have more area to store the charge. How about if now we divide these same 1 centimeter cubes into 1 millimeter cubes? So the surface area of each one of those 1 millimeter cubes is going to be 1 times 1 times 6. So we have 6 millimeter square, and the total number of 1 millimeter cubes in here will be 1,000,000. So 1,000,000 times 6, that will be 6 million square millimeters, or 60,000 square centimeters. Wow. Well, how about if each one of those 1 millimeter cube we divide it into nanometer cubes? 1 millimeter is equal to 1 million nanometers. So in each cube of 1 millimeter in length, we will have 1 million times 1 million times 1 million cubes of 1 nanometer. It's getting a bit complicated, right? Well, we will have 1 times 10 to the 18 power cubes of 1 nanometer in length. And as we saw, we have 1,000 cubes of 1 millimeter in the 1 centimeter cubes, and we have 1,000 1 centimeter cubes in the original 10 centimeter cube. Okay, you can pause and do the math. So in my original cube, we have 1 times 10 to the 24 cubes of 1 nanometer in length times 6 sides in each one of the cubes. Well, that's a surface area of 6 times 10 to the 24 square nanometers, which equals to 60,000 million square centimeters. Wait, remember, we started with 600 square centimeter, and again with the same mass, just what it's in this cube. Wow, let's put this into perspective. If you take these nanocubes and you lay them flat, we're going to have enough to cover 1,500 football fields. 1,500 football fields. Wow, yes, that's twice the amount of area that is in Central Park in New York. Wow, that's a lot of cubes in here. I have a lot of power in my hands right now. Wow, this is mind-blowing. Nanotechnologies can design smart systems that with the same mass, they can completely change the properties with surface area. Surface area is very, very, very important. Now, keep an eye to a follow-up video where we will relate surface area to a diet. We're going to talk about how we can lose weight and be healthier if we use surface area or if we have surface area in mind. Hope you learned something about surface area and see you in the next video. Bye.